Hello everyone, in this module we are going to learn the working of universal function. So we have already seen in the previous module that NumPy is quite a vast and complex module. So in this module, let's see what the universal functions are. So with universal function we can easily perform on the NumPy array and do element wise operations on the data element. So at the basic level, the universal functions are a part of NumPy.u function class of Python. Also with universal function, we can internally invoke of basic mathematically functions during a runtime execution instead of operators. For example, if we want to perform a plus b using universal functions, then we can easily use universal function, that is numpy.add function. So till now we have covered mathematical and statistical functions on NumPy arrays. Now we will understand other functions based on universal function. Now we will discuss some basic functions of universal functions, that is floating functions and bit twiddling function. Now we will understand these functions on NumPy array. So our first function is numpy.is finite. Basically this function is available in the NumPy package module and it will check the condition the value is finite or not in array, and it will return the boolean value. That means the output will be true or false. So we can also pass input arrays to check whether the values are available in the array belonging to the finite class. If it is finite, then it will return the true value, otherwise it will return false. So here is the syntax of NumPy is finite function, and within this function we are going to use only 4 parameters. The first one parameter is x. This parameter indicates the input array in which we want to check whether the value is finite or not. The next one parameter is out. This parameter specifies the location where the result will be stored, and by default it takes none value. Our third parameter is where. This parameter specifies that the universal function should be calculated at that position. The next one parameter is dtype. It is an optional parameter and it specifies the type of the input array. Now let us see an example of how to use the NumPy is finite function with an integer value as an argument. So in this example, first we have created an input array named as random numbers by using np.array function, and inside the function we have set the integer and nan value as an argument. Now we are going to use the np.isFinite function, and within this function we have set the input array, that is random number. So it will return boolean values depending upon if the values are positive or negative nan values, and it will return false. So as you can see, if the value is integer, it will return a true value. If the value is nan, it will return a false value. So our next function is infinite function. So basically this function tests if an element is a positive or negative infinity. So this function takes 2 parameters, out of which one is an optional parameter, and we can pass the arrays also to check whether the items present in the array that belongs to positive infinity or negative class. If it is not positive or negative infinity, the method returns false, otherwise it will return true. So this function always returns boolean values. The first parameter is an input array that we want to check whether it is positive infinity or negative infinity. The second parameter is an n-dimensional array which is an optional, and it is the output array which is placed with the result. Now we will see an example and understand the NumPy is infinite function. In this example, first we have created an input array named as sample number by using np.array function, and within this function we have set the integer values, infinite value, by using np.inf, and along with that we have used nan value. So after that we have used the np.isInfinite function, and within this function we have mentioned the input array as an argument. So after executing this code, the output comes the boolean values. The first value is false because we have take our first value, integer value, that's why it displays the false value. In next case we have mentioned the negative infinite value and it will return the true value. So our next function is, that is numpy.isNan function. So basically this function checks element wise whether it is nan or not, and it always returns the result as a boolean array. So again, this function takes two mainly parameters that we are going to use in an example, and we can also pass the arrays to check whether the items present in the array that belongs to the nan class or not. If it is nan, the method returns true, otherwise it will return false value. So here is the syntax of numpy.isNan function, and within this function there are lots of parameters, but we are going to use mainly two parameters. The first parameter is input array, for which we want to check whether it is nan or not. The second one parameter is the n-dimensional array, which is an optional parameter, and it defines the output array that has placed with the result. Now let us see an example of how to use the numpy.isNan function. So in this example, what we are doing, we have created an array by using np.array function, and within this function we have assigned integer along with the nan value as an argument. Next, we use the np.isNan function, and within this function we have passed input array as an argument. So after executing this code, the output comes a boolean values. The first value has false value because we have take an integer value in input array. As you can see that it display also a true value because we have mentioned the nan value in an input array, and by using this function it will calculate whether it is nan or not. So our next function is numpy.floor function. So basically numpy.floor is a mathematically function that returns the floor of the elements of the array. The numpy floor function accepts two main parameters, and it will return the float value of each array elements with the float data type. So this method checks the value of the input variable, and it must be a real number, and rounds the variable in a downwards manner to the nearest integer, and finally it will return the floor value output. Now let us see an example of how to use the numpy floor function with that floating value as an argument. So in this example, first we have declared an array by using np.array function, and within this function we have assigned the floating values as an argument. So after using the np.floor function, it will return the floor value of the given array element. Now we will understand our next function, that is numpy truncated function. So basically this function is used to calculate the truncated value of the given array, and the truncated value must be an integer value that is closer to 0 rather than to x, where x is the input value. So again, this function takes two parameters. The first parameter is array, whose elements are to be truncated, and the second parameter is out, that specifies the location. Now we will discuss the example by using the numpy truncated function. So in this example, we have created an array named as sample numbers that contains multiple decimal values, and after creating an array, we have used the numpy truncated function, and within this function we have assigned the input array as an argument. So after executing this code, the output comes the nearest value of input array. Our next function is numpy.isNat function. So this function will return the boolean value, and it will check the input array element wise whether it defines NAT values or not. So to test element wise for NAT, use the numpy.isNat function, and it will checks the value for date time or time delta data type, and the condition is broadcast over the input at location where the condition is true, and the NAT stands for not a time value. Now we will understand the example by using the numpy.isNat function. So in this example, we have used the np.isNat function, and within this function we have used the np.datetime64 method and assigned the string value as an argument. After executing this code, it displays the output comes the true value because we have mentioned the nat value as a string in argument. So in the next case, we have used the np.isNat function, and within this function we have used the date time string. So after executing this code, it displays the false value. Now we will discuss our next function, that is numpy.seal. So basically this function is available in NumPy package module, and it is used to calculate the seal of the elements of given array, and this function takes two parameters which are array and out, and it will return the rounded value of each element. So for example, if the input value is 8.89, and by using the numpy.seal function, it will return the 9 value. Now we will see an example by using the NumPy.seal function. So in this example we have created a one-dimensional array whose values are in decimal form, and then we have used the np.seal function, and within this function we have assigned the input array as an argument. So it will return the seal values, which means the input values are greater than or equal to the respective values. So as you can see that our first input value is 8.89, and by using the np.seal function it will return a 9 value. Now we will discuss our next universal function, that is bit twiddling function. Now let us briefly understand about these functions. So our first function is numpy.bitwise AND operation. So basically this function is used to find the bitwise AND operation of two numpy arrays, and it will check the condition. If the both values are 1, then the output will always return 1 value. If the first input value is 1 and the second input value is 0, then it will return a 0 value. So here is the syntax of numpy.bitwise AND operation function, and within this function we are going to use three main parameters. The first parameters are input arrays x1 and x2. These parameters specifies the input array, and it takes only integer and boolean values as an argument. Now we will take an example by using the numpy.bitwise AND function. So in this example we have created two input arrays. The first input array is user ID and the next input array is employee ID by using the np.array function, and within this function we have set the integer value as an argument. After that we have used the np.bitwise AND operation, and it will calculate two input arrays. After executing this code, it displays a new list. So our next function is numpy.invert. Basically this function is used to invert the input array. For example, if the input array is a signed integer, then this function will easily returns the 2's complement, and the purpose of this function is to calculate the bitwise inversion. Now let us see an example of how to use the numpy.invert function. So in this example we have created an array named as a number of pencils sold. So after creating an array we have used the np.invert function for inversion of input array, and within this function we have set the input array as an argument. So after executing this code, the result input array after inversion is this. Now we will discuss our next function, that is left shift function. So basically this function is mainly used to perform the left shift operation, and it is mainly used in order to shift the bits of an integer to the left, and it always return x1 with bits shifted x2 times to the where x1 and x2 are the input arrays, and it will check the condition. If the input arrays are scalar, then it will return the scalar. Now we will discuss the example by using the left shift function. In this example we have created two input arrays named as random number and shift val. After creating an array we have used the numpy left shift function, and within this function we have set the input arrays as an argument. So after executing this code, it will shift the bits of integer. So with this we have completed the working of universal functions.